Okay, now let's prove triangle sum theorem. So what does triangle sum theorem say? It basically says that if you have any triangle, the sum of its interior angles, A, B, and C, these three angles, 1, 2, 3, is equal to 180 degrees. Now, to show this, we need to start off with an axiom, okay? And I'm going to call it the parallel line axiom. Okay, so what does the parallel line axiom say? It says that if a point exists off a line, then there exists one line through that point that's parallel to the line. So what does it look like? It looks like this. Here's some line L. Here's a point off of L. The parallel line axiom says that there exists one line through P that's parallel to L. And we should see that when we draw it like this. Okay, this line is, let's say, through P and parallel to L. Okay, that's the idea. That's the parallel line axiom. If you have a line and a point, there exists one line through that point that's parallel to the given line. So how do we use that here? Well, if you look, of course, I could extend this, but it's pointless, right? We could just talk about parallel between the segments, but point B is clearly off of the line AC. So since point B is off of the line AC, there exists one line through B parallel to AC. So we draw that line, we could call it line M, whatever. Okay? Now that we have line M, we have these new angles that were created. Let's call this angle X, and then this angle over here Y. Now we should see that X plus B plus Y is clearly 180 degrees. So let's just write that, okay? Let's just write the measure of X plus the measure of B. So we're not writing it yet. We're still just going through theory, right? Is equal to 180 degrees, okay? Then we should see that since I constructed M so it's parallel to AC, right? These two lines are parallel. I can use alternate interior angles theorem to say that X is the same as A and that for Y is the same as C. We should see that X and A are alternate interior. If I extend this and look at this as a transversal, right, then you should see that X is alternate interior with A. So then that means that the measure of X will ultimately be equal to the measure of A. Similarly, right, I could show with this being the transversal, and I forget about the other transversal, that Y is going to be the same as C. So I could say that the measure of C is going to be equal to the measure of Y. And then with this, instead of writing X here, I could write A. And then instead of writing Y here, I could write C. And then I get my conclusion that the measure of A plus the measure of B plus the measure of C is equal to 180, right? Because again, X is the same as A. So instead of writing, or X is the same as A from this line, right? So instead of writing X, I can write A. And then C is the same as Y. So instead of writing Y, I can write C. And then I get the result that I needed, right? I exchanged, in this equation, I exchanged X for A and Y for C. Now let's write it more neatly. So let's start off with what we said in the very beginning. I want to get this picture back to where it was. So let's get this picture back to where it was. You should go through that theory. Make sure the theory makes sense before you even begin to write it. And let's see what we have. So what did I say originally? What was this axiom that we need to just make sure we state correctly, right? Okay, let's see. There we go. Okay. By parallel line axiom, okay, there exists L parallel to AC through B. Draw L. Okay, so it helps us with our proof. Otherwise, we won't be able to see anything if we don't draw L. So we draw L. And then what we say now is we label these newly created angles X and Y. And then we can say the measure of X plus the measure of B plus the measure of Y is equal to 180 degrees because they form the line. They form L. They form line L. Okay? Now we're going to say that angle X is congruent to angle A by alternate interior angles theorem, because these two lines are parallel. L and AC are parallel. Okay, so we can use what is alternate interior angles theorem say? It says if the lines are parallel, then alternate interior angles are congruent. So by alternate interior angles theorem, right, we know that A is congruent to X or X is congruent to A, and then also we have, by the same reasoning, Y is congruent to C by alternate interior angles theorem. Then we can say that the measures are equal. So we got to talk about measures, right? Because here we have a measure of angle X. Here we have a measure of angle Y, right? So we got to say the measure of X is equal to the measure of A by, and I'm just going to write the same thing for Y, right? Y and C, right? By definition, and you could do this as well. These two are both the same reason. By definition of congruent angles. Okay, then you could say by substitution, what did I do here? By substitution. By substitution, right, look, in this first equation, right, X is the same as A from this equation. So by substitution, I could substitute X for A, the measure of X for the measure of A, plus the measure of B just stays, and then I substitute for Y, I substitute C for Y, and then I get that this must equal 180 degrees, and that this will work for any triangle. And I've ended with my conclusion. This here, I ended with this last statement, showing that for any triangle, the sum of these angles is 180 degrees.